Hello everyone, and welcome to yet another day in the Azure Advent Calendar. In this recording I will be talking to you about the topic of Logic Apps. Logic Apps are the Microsoft Azure low-code offering that allow you to quickly solve business problems that require you to integrate one or more other software products. As you may have found already, there are actually two recordings on Logic Apps. The first one was by Simon White and covered all the basics around Logic Apps. In this recording, we will build on that knowledge. Let's go. There are three topics that we will dive into in this recording. First, we will explore a real-world use case where I have used Logic Apps to solve a simple integration problem. The main point here is how the use of Logic Apps ensured that I did not have to worry about all kinds of nitty-gritty details. Next, we will explore how we can apply modern DevOps practices when working with Logic Apps. We will start by translating a Logic app that was built using the graphical designer to its JSON counterpart. This way we can store the definition of our Logic app in source control. Once this is done, we will see how we can use Azure pipelines to deploy the Logic app into Azure. Finally, we will take a quick look at how you can build your own connectors. As Simon already explained, there are hundreds of connectors already available to you. However, if there is no connector for the system that you want to integrate with, you can create one yourself. This is useful if you find that you are in need of integrating between multiple systems you own. Let's start by exploring the real-world use case I mentioned earlier. About 2 years ago, I was tasked with creating a simple portal for a customer of mine. The main goal of that portal was to present data from an internal system to end users. A simple ASP.NET Core application backed by an Cosmos DB was born. After some designing and some proof of concepts, only one question remained: how to get the data from the existing system into the new portal. To do this, the vendor of the application, with the source data, offered a means for getting that data into our application. They would generate an XML file with all the changes whenever a record was changed. The portal application should then fetch that file and process it. While this sounds as an easy task at first, there might be more to it than you might think. How to go about questions as running exactly once, guaranteeing running in order, restarting the processing of a file if the server is down, or restarting the processing of failed messages in case of a bug, and many more. The answer to many of these questions will be the usage of a queue for managing the processing of files. To make this possible, the choice was made to upload a copy of every file from the FTP server to a blob storage and put a reference to that file on the queue after uploading. This way the queue can be used as a means for managing locking, concurrency and retries from the consuming application's point of view, in this case through an Azure function. But how to get the files to their blob storage and the queue in a reliable way? This in itself can be a fair bit of work if you have to write code for this. However, not with Logic Apps. And thus the following Logic app was created. Here you see a Logic app resource in the Azure portal. Let's edit the workflow to see what it looks like. You can see a workflow similar to the one that was demonstrated by Simon. The trigger for this workflow is the availability of a new file on the FTP server. Since FTP does not provide a notification when a new file is available, this is called a polling trigger. For a polling trigger, you have to specify how often to check for new items or files. Please note that you are also being charged for every poll operation, even if there are no files, so choose your interval wisely. Whenever a new file is available, that file should be uploaded to the blob storage. Here I am using an expression to generate a new, unique name for the file. Once the file is uploaded, we put a reference to that file on the queue. This order of tasks ensures that the workflow is reentrant, meaning that it can restart in case of an error, and the final result will be the same. Yes, we do have the risk of having duplicate files in blob storage, but since there is no reference to that file on the queue, it will not be processed twice. Besides this, the runtime properties of a Logic app guarantee retry of individual operations, and the edit or modified file trigger guarantees that any change will be picked up, even if the connection is unavailable. And as you can see right here, our service connection is working properly. However, building a workflow like this in the portal is not a way of delivering software that I would advise. And next to that, I doubt that anyone would enjoy rebuilding a workflow like this for dev, test and production environments for any application. Thus it is time to explore how we can take this workflow and see if we can apply modern DevOps practices to it. To do this, we are going to apply the principle of infrastructure as code. Instead of defining our logic app visually, we are going to define it in JSON, specifically as an ARM template. This way we can store the file in source control, in GitHub or an Azure repo, and deploy it from GitHub Actions or Azure pipelines. This way we can create repeatable deployments that are guaranteed to have the same result when deployed from environment to environment. Now today I will skip over working with repositories or pipelines and will focus on creating the ARM template. Specifically, we will go through the following steps. First we will create an empty ARM template. To the template we will add a JSON definition of the logic app you just saw. This is actually a common approach. First create the app visually, then reverse engineer it to an ARM template. Once this is done, we will see how this will give us only the logic app, not the dependencies it needs. And dependencies are things like the connections to the FTP server. So next we will add those. Finally, we will parameterize the template and add parameter files so that we can use the same template for multiple environments but with minimal repetition. Let's go! To get started, I have already created an ARM template that you can see right here. Detailed information about ARM templates can be found in numerous sources, but for now it is important to understand that we have three important parts in our template to deal with: parameters, variables, and resources. Parameters are values that we can pass in when we are deploying the template. Variables are for expressions that we will use multiple times but do not want to repeat, and resources is an array with all the Azure resources that we want to describe. To build our logic app and its dependencies in an ARM template, we first have to add a storage account to our template. The syntax to do this is this. This is something I prepared in advance, so let's copy it in. The storage account is our first resource that we need to host for our logic app. As every resource you declare, it has to specify at least a type, name, API version, and location. And as you can see, I am not specifying literals everywhere. In some locations I am using brackets inside a JSON string to use ARM functions. The resource group function can be used to retrieve properties of the resource group that the current deployment is targeting, like the location. This way I do not have to repeat the location every time, and I ensure that all my resources are in the same location. For the name of the resource I am looking up a variable with the name of storage account name. So let's declare that variable at the top. The declaration is done by specifying an object which declares the type of the parameter. This completes the specification of the storage account. So let's now move on to declaring connections. Remember that when using triggers and actions, you had to create or reuse a connection to the service you were performing that action against. These connections are resources in themselves, and we need to create them for our template as well. Let's start with the Blob connection that runs on top of our storage account. Instead of specifying the JSON from scratch, I am looking it up by opening the resource in the portal and navigating to Export Template. From here I can copy the declared JSON and work from that. By the way, this is a technique that you can use for many resources in Azure. The first thing I change here is the name of the parameter used for the connection name, just to ensure that everything is uniform. Next I copy and paste this expression to reuse it as the display name for my connection as well. For the location, I am again using an ARM function. Now it is time to move on to the connection specific properties. First I remove the empty and unused custom parameters value object. When moving further down, we encounter the URL of the managed API connection type that is the basis of my Blob connection. While this URL is probably correct, I still want to change this. I need to remove all hard-coded references to my subscription, resource group name, location, etc. If I do not do this, I will not be able to reuse my template to deploy to different environments like a test and production environment. So first let's replace the hard-coded reference to my subscription by the call to another function, subscription. This function returns an object with the property ID, which contains the full ID of my subscription, so including the leading /subscriptions/. Next we replace the location again. And finally, we replaced an unnecessary variable with the hard-coded name of the pre-provisioned Blob API. Now it is time to add a final property, parameter values. Here we have to specify all the values that are specific to this type of connection. For a Blob connection, these are the account name and the access key. And we will see later on how you can find the properties that you need for each type of connection. Now as you can see, I'm not specifying that access key directly, but I'm using a lookup function to pass the key around within Azure and not having to specify it manually. To do this, I am reusing an expression, account ID, which I thus have to add to the variables section of the template. Let's also add the new parameter so my Blob connection is complete. If I now repeat this process for another connection type, I will end up with the following JSON. This is the complete specification for the connection to the queue. And if I repeat it a third time, I now also have my connection to the FTP server. And these are all the connections I will need. I will add all the new parameters later to prevent this recording from becoming even more boring. But I do have to add one more property to my Blob connection before we can continue. This is the declaration of a dependency from my Blob connection to the storage account. I do this by specifying the complete resource ID of that storage account in the depends on array. This way I ensure that ARM will wait for the storage account to be created before trying to create this connection. Now, before we move on from here and add the logic workflow on top of all this, there is one more thing you should know. Remember those connection specific properties I was talking about? Unfortunately, they are not exported when reverse engineering a template in the portal, and in many other places they are also omitted, most likely because they might contain passwords and usernames. To still be able to find these parameter names, you can use the following Azure CLI command. To identify the parameters for a managed connection type, just replace the subscription ID, resource location, and of course the name of the connection type, and you will be given a JSON response containing all the information you need. Okay, and that's all the groundwork we need to do. Let's now move on to creating the workflow itself. The third thing we have to do here is to add a Logic App workflow to our template. The following snippet is the declaration of such a workflow. Here you see the common properties again: type, name, location, API version, and depends on. Besides this, there is the properties object where we can fill in the details of our specific workflow. To get these details, we are yet again reverse engineering the JSON, but this time from the Logic App itself. To do this, we go to the portal, open the editor, and now navigate to the code view. From here we can copy both the definition and parameter objects and paste them into our template. Once this is done, the only task remaining is to ensure that the definition is parameterized, so that it can be deployed to multiple environments using the correct parameters. Let's do this simply from top to bottom. The first thing to update is the folder path in the create blob action. Let's not hardcode to the inbound dev folder, but instead refer back to one of the template parameters. Next up is the path that the FTP trigger should pull its files from. Right now this is hardcoded to /dev. Please note the indirection from the folder ID in the query to the actual folder under that folder ID in the metadata. This makes updating it a little bit tricky. We start by replacing the actual folder with a reference back to the parameter. But next we also have to update the folder ID. This is not random as string. This should be a base 64 encoded version of the same path. These are all the replacements we have to make to the definition. Next up is a series of replacements as we have seen before. In all the parameters, we have to substitute hard-coded references to the resources and the managed APIs in the current subscription. Finally, we have to declare all the parameters we use, a thing I have prepared already, so let's just paste that in and correct a small error I just spotted. Of course, just declaring parameters is not good enough. We also need to supply them. This can be done from Azure Pipelines or the command line when rolling out the template, but it is good practice to add a parameter file containing all the values for a single environment, excluding the secrets. Secrets do not belong in source control, ever. So there are a number of alternative approaches for handling secrets, but for today that is out of scope. The one value I am not providing right now is my FTP service password. I will provide that on the command line, since I do not want to enter it into this file, into source control. And once we have this file, we can just resave it as the parameters for production and make the appropriate changes. To prove that this is all working, let's quickly deploy the template into Azure using the new -Azure RM resource group deployment command. This is part of the Azure RM modules for PowerShell that you have to install if you haven't done so. After putting in the name of the new resource group and references to the template and parameter files, everything should deploy. Well, that is, if you don't make mistakes like I do. So I made another small mistake, so let's correct that quickly and do a retry. And apparently this time I made no more mistakes and everything is working. So roughly 1 or 2 minutes later my deployment is done. Now navigating to the portal, I can click the refresh button for this resource group and see that everything is deployed correctly. Now from here it is fairly easy to incorporate the delivery of Logic Apps into your Azure pipelines. Just take a quick look at this example that I have created before for another project. As you can see, it is just a simple built-in step that can be used to deploy the template. You specify the template file and the parameter file, and there you go. This completes the demonstration of continuous deployment for Logic Apps. Let's now take the final few minutes of this recording to take a look at custom connectors. Custom connectors are a way for you to add your own actions to the Logic Apps library. You can do this by building a custom connector from scratch, by wrapping an API that is described using SOAP, or by wrapping an API that is described using OpenAPI, formerly known as Swagger. In the following demo, we will take a look at the simplest approach to using custom connectors, the one using OpenAPI. This is also quite a common scenario. If you want to create a connector to an API that you own, it makes sense to add an OpenAPI specification for that API, just to make creating the connector as straightforward as possible. As you can see, here I have created a simple API. Now next to this I have added an OpenAPI specification. And under the hood OpenAPI uses JSON, which you can see here. Now let's navigate to the portal and create a custom connector out of this API. To do this, we find a custom connector resource in the new blade and create a new instance out of it. We specify a name and a resource group for hosting the connector. Now creating the connector can take a few seconds, so fast forward. And once the connector is created, we can navigate to the new resource and directly start editing it. The first thing we have to do is to load the OpenAPI spec. One approach to do this is by specifying the URL to the JSON file. Unfortunately, sometimes this does not work, as you can see right here from this almost hidden error. So as an alternative, I have downloaded the JSON file already and have uploaded it from my own computer. Next we scroll down, where we can specify an icon and a color, which we will not do, and a description for our connector. Now let's do that to ensure we can find it later on. Finally, we have to specify the URL where our API is hosted. And with that, we are done on this page of the wizard. The page for configuring security and authentication we can skip, since my API does not require authentication. If yours does, most common authentication schemes are supported. On the third and final page, we have to define the different operations that the API supports. As you can see, the OpenAPI file has been parsed and two operations, get and post, have been found. And now I have to document those two. First, I specify the summary and description for the get operation. Next, I select the post operation on the left and specify a description and a summary for that one as well. All the other configuration is automatically parsed out of the JSON file, so we can just scroll down and move on to save the connector. And with that, our connector is ready for use. So going back to the previously defined logic app, we can enter edit mode again. Now here let's add a fourth step to the workflow, and in the filter bar we can go to the custom connectors. Here we find our previously created connector and the two actions we specified. Let's go for posting a value, for example the file content. And from here we can just save the logic app again, just as we've done before, and we are ready to go. And that wraps up this short demo of custom connectors. And that's really all I wanted to show, so thank you again for joining me, and I hope you really enjoyed this short introduction into a Logic Apps use case, CI/CD for Logic Apps, and a quick demo of custom connectors. So let's wrap up my contribution to the Azure Advent Calendar, and I really wish you a Merry Christmas and a very good New Year.